Hi girls, so we are going to be starting a brand new unit. I mentioned on your progress reports that went home that we were going to be dipping our toes into a new unit and looking at trigonometry since our course is Algebra 2 and trigonometry. So we're going to be looking at specifically triangle trigonometry, but before we get into looking at triangles, we need to really understand angles and degree measure. And so this first section of chapter 12 deals with exactly that. So on your notes, I provided you with, it's an applet to GeoGebra. So if you pull up this notes on your computer, you actually will be able to access the website that this goes to. But I just have a static figure here that we're just going to talk about so that you can understand some of the terminology. But I do encourage you to actually play around with the applet and see, like, when you change the position of the terminal side, what happens to your angle and what happens to the coterminal angle. So I'm going to go through some of this terminology with you. So this is considered a standard position angle. And you can see that the red ray here is called the initial side, and you can see that the blue ray here is called the terminal side. And you notice that this marker up here, this is theta, which is the Greek letter that we use a lot in trigonometry, that just gives you the name of an angle. And we know that this theta is equal to 60 degrees, which you can see over here. The amount of opening here is 60 degrees. We also, in this figure, are showing something called the coterminal angle, which is the angle that is in the opposite direction. So if I were to travel in the opposite direction, I would get an angle of negative 300 degrees. So it's really important to notice that if you are going counterclockwise, so I'm going to just write this for your notes, counterclockwise, your angle is a positive angle, right? Positive degree. And then if you were going clockwise, you're going to get a negative degree. And just as a review, you know that if you do a full rotation, that will give you a total of 360 degrees. So that's why we have 60 degrees as a positive, and then if I go the other way, that's a negative 300. The other thing just to notice is that this angle happens to be in quadrant 1. We know that this would be quadrant 2, quadrant 3, and quadrant 4. And then I think what we're going to do is we're just going to look at how to find out different coterminal angles based on this idea of a full rotation. So let's scroll down and take a look at this. So we have the measure of all angles coterminal with a 60-degree angle are given by the expression 60 degrees plus n times 360, where n is an integer. So n basically represents how many times we're going to make a rotation. So for example, I'm just going to sketch this right here. If I had my coordinate plane and I still have my 60-degree angle here, and I want to do a rotation, so I'm starting here on my initial side, and I'm going to rotate once, twice, and land here. So I want to find out what is my coterminal angle here. So I'm going to take my degree angle, which is 60, and then I'm going to look and see how many times I actually rotated through. So I'm going to actually do this in yellow so we could see. So this is one full rotation, and then I'm going to pick up another color, and 2 full rotations. So that means that I'm going to do 60 plus 2 times 360 degrees. And then I have my additional 60 degrees here. That's going to give me my total amount of degrees that I have traveled. So I'm going to use my order of operations. I'm going to multiply first. So it's going to give me 60 degrees plus 720 degrees. And that will give me a total answer of 780 degrees total. So that's what it means by your coterminal angles. All right, so now let's take a look at using this formula when we have different degree measures. So in example 1, we're asked to write a formula for the measures of all angles coterminal with 30-degree angle. We're going to use the formula to find 2 positive angles and 2 negative angles that are coterminal with a 30-degree angle. So we're going to just start off with our formula. So since we know it's 30 degrees, we're going to have 30 degrees plus n times a full rotation, which is 360 degrees. And we're asked to find 2 positive and 2 negative values. So basically what that means is we're going to let n equal 1 and 2, 1 rotation and 2 rotations to show our positive, and then we'll show when n is equal to -1 rotations and -2 rotations. So that's going in the opposite direction. So when n is equal to 1, we would get 30 plus 1 times 360, and that would give us an answer of 390 degrees. And then next we would do 30 plus 2 times 360. So again, we're multiplying 2 times 360 first and then adding 30, and that would give us 750 degrees. So those would be 2 positive coterminal angles. And then let's take a look when we do an opposite rotation. So when we go in a negative direction, we're going to plug in -1. So that's 30 plus -1 times 360. So that's going to give you -360 plus 30, which is going to give you an angle measure of -330 degrees. And then again, 30 plus -2 times 360. And we're going to get -720 plus your 30, which will give you -690 degrees. And one way you can always check, I think is helpful visually, is if I were to draw that coordinate plane and then I draw my 30-degree angle here, and I think about 1 full rotation would be 360 plus my 30, which does check out to give me 90. And I could do the same thing if I kept going with this. Right? So this would be 360, 720, plus my 30 to give me 750. And then you could do the opposite is true here. So you would start with your angle and go around. And you can always check. All right, so let's go ahead and scroll down and take a look at a couple of other applications to this. So sometimes when you measure angles more precisely than to the nearest degree, you can use either decimal degrees or you can convert them into minutes and seconds. So a minute is equal to 1/60th of a degree. And then 1 second is obviously 1/60th of a minute, which then would be equal to 1/3600 of a degree. So we're going to use these conversions to help us express these decimals, or express these degrees in decimals, and then also in minutes and seconds. So let's start off with our first example. So we have 14 degrees, 36 minutes, and 54 seconds. So we're going to just start off with keeping our 14 degrees. Now I have 36 minutes, which is essentially adding 36 out of 60. And then I'm going to add my 54 out of 3,600. And then what we're going to do is convert these into decimals. So you just need a calculator handy. I forgot to add my little degree marks there. So go ahead and calculate 36 divided by 60. And so you get an answer of 0.6 degrees. And then go ahead and divide 54 divided by 3,600. When you divide that, you get 0.015 degrees. So then you just add all of that together and you get an answer of 14.615 degrees. All right, so go ahead and pause the video and go ahead and try the next one on your own. All right, so just like the last example, we're going to keep 64 degrees out since that's already in degree notation. And we just have this 9 minutes, so we're going to add 9 out of 60. So go ahead and divide 9 divided by 60, and you get 64 degrees plus 0.15 degrees. And you're just going to add all of that together, so you get 64.15 degrees as your total. All right, so of course we're going to work in the opposite way. So we're going to change our decimal notation to minutes and seconds. So let's go ahead and go through an example together. Sorry, I don't know why it keeps moving that quickly up. So let's take a look at these problems. So just like we were dividing by 60, in these examples we're going to do the opposite. So we're going to end up multiplying by 60. So we're going to start off with our whole number, which is 72. So we're going to pull that out. So we have 72 degrees. And then we're going to break down our decimal. So I've got this 0.568 degrees that I'm going to multiply by 60 to get my minutes. So that little hash mark means minutes. So when I do that, I get 72 still stays outside. And then I'm going to get an answer of 34.08 minutes. So then I want to take this 0.08 minutes and I want to change that into seconds. So I'm going to go ahead and put my 72 degrees here. I've got my 34 minutes, and then this time I'm going to multiply my 0.08 times 60 again to get my seconds. So when I multiply 0.8 times 60, I get 72 degrees plus 34 minutes plus 4.8 seconds. But if I go back to my directions, it says my seconds to the nearest second. So I'm going to round this. So my final answer becomes 72 degrees, 34 minutes, and 5 seconds. And that would be your final answer. All right, so go ahead and pause the video and try part B, and then you can check your work when you finish. All right, so just like the last example, I'm going to pull out my 53 degrees, and then I'm going to add 0.721 times 60 to get my minutes. So that's 53 degrees plus 43.26 minutes. So then I'm going to rewrite this as 53 degrees plus 43 minutes plus 0.26 times 60 to get my seconds. So I end up with 53 degrees plus 43 minutes plus 15.6 seconds. So I'm going to go ahead and again round because I'm looking to the nearest second. So my final answer becomes 53 degrees, 43 minutes, and 16 seconds. And that would be my final answer for that problem. All right, you have a couple of problems to complete out of the textbook, and we will pick up at our next session. All right, bye.